recap videos. Quite a few people that seem to get a little bit confused with some of the questions, so I thought that if I pick one of the two of the ones that a lot of people struggled with, and then we can go over essentially kind of where it went wrong. So I think just to key points to remember with the linked list is it is just using an array, or you can actually use a list in Python in order to have data stored non-contiguously. Okay, so remember we've kind of got our image, if you like, and each one, so we just assign letters and then we say the indexing position. So remember that the reason we think about indexing positions is because we know that we're going to be using an array. Okay, so if I, for example, L, R and B, I know that if this list is just imported as it is right now, then I know that L is going to point to index position 1. Okay, R is then going to point to index position 2. And 2, I'm going to do some different colour. B is going to point to null, because at the moment there is nothing in there. Let's find one that works. Okay, so with that in mind, if, for example, I ask you then to add the letter S into the list, we would need to add a whole new box, which we're going to do down the bottom. So we're just going to get that to sort of continue over here. I can't remember what letter I just said, but we'll say S. Okay, we then need to update this index position, and then we need to make sure that we change that to null. And I think everyone's pretty good when it gets to this point. Where people started to go wrong was when it asked you how to remove items and add items, etc. So most people do pretty good on the question around removing, I think it was Birmingham, and adding York. So if we say remove R and add the letter T instead, okay? Now there's two different ways this can be done. The first way is that we just add T to the end of this, because we might not have deleted Birmingham first. So say we add, where are we, T, okay, and then what we can actually do is we don't even have to necessarily delete Birmingham, but we can use the pointers to skip over. We now need to go through and update the index positions, so this becomes null, and if we kind of then work from the front, we're now saying that this one essentially doesn't exist. So with that in mind, this is now pointing to 2 instead. This one is still pointing to 3 and onwards to 4. Does that make sense? Okay, so with that question, you could either approach it two ways, in that you could remove Birmingham and then you just adjusted the pointers so that this one ended up being York, I think, with null, or you just add another one and then you just essentially kind of bypass it. Okay, either of those answers work because you're just using the pointers to be able to achieve that. Okay, so hopefully that makes a bit of sense. Okay, oh, that was horrible and loud. So next bit then was understanding, I think this is where I know a lot of people got a little bit confused. It was when you had to add 159 into the list. Okay, so it gave us a current table, and it was made up of 3 columns. We had our index position, or kind of our nodes number, and then we also, and it had some data and it wanted us to make some changes. So I want to talk through this question because there was only, I think, 2 people that actually got this one right. In fact, I don't know if everyone got this one 100% right. So 0, 1, 2 and 3, and the current data that we had in there was 154, 157, 155 and 156, and then it points, so obviously this is going to point to 1, 2, 3, and I'm actually going to write the word null in there. So the first question was order 158 has been made and needs adding to the end of the linked list. Now that one was really straightforward. Most people knew just to add it in here and then to update this pointer. Okay, easy enough. The next one, however, it says order 159 has been made. the order has a higher priority and needs to be second order in the linked list. Add order 159 to the original linked list. Okay. Now, this doesn't mean that any of the other items are being moved. And what a lot of people did was they took 157, they put it down the bottom. But actually, remember what I just showed you? What they wanted you to understand was that you're using pointers correctly. So what they actually wanted to see, and what I would expect to see, is that you simply add 159, but now you have to go through and you have to amend the pointers. Currently, the next item in the list, so this will remain order number 1, and it says it wants it to be the second number in the list. Yeah, it needs to be the second order in the linked list. We then just update this so that this now points to 5. This is second. This then regains its position of third, and so I want to say I'm going to point to 1. From there, the next item is going to be 2. The next item is going to be 3, 4, and then null. Now, if I use this truth table to recall my list in order, and this is something that you do need to learn how to do, if I start at the top, my order, if I follow the table, that takes me to 1, that takes me to 2, and essentially tracing through my table, I should get the order, the original order, but with 159 now inserted, and you can see that that does work. So that was just an important point that I really wanted to point out. And then I think the next one that a lot of people struggled with was understanding, okay, so there was this one here. So a new order 190 has been added to the orders array. It needs to be the third element in the list. The current contents of the array are repeated here for reference. Okay, so this is, again, a really similar type of question. And it asks you to describe how the new order 190 can be added to the array so that the linked list is read in the correct order without rearranging the array elements. So it was really leading you back to this question. So I'm going to just clear this. I'll actually pick it up this time. Okay. And I'm just going to draw out that table so that you can remember the question I'm talking about. So it was 184, 186, 185 and 187, and there was space for additional orders, and it had 1, 2, 3, and this was currently null. Now remember that this is index position 0, 1, 2, 3 and 4. So when it says 1, it's saying the next item can be found there. Okay, I think that threw a couple of people off when they answered this question. So it says, how do we add 190? So I know 190 needs to go in the next available space because nothing's been deleted, but now it needs to be the third element in the list. Now that doesn't mean it needs to be in the third index position. That is just, you need to kind of take it out of abstract context. It doesn't matter what index position is, but when I do my trace table in a second, it should be the third number that I get from my list. And the way that I just do that is I leave 184 as the first number, the second, but now this doesn't want to point to 2, this needs to point to 4. Remember we talked about that. Then I need to rearrange it, to kind of rewrite the table. So 190, the next logical number then is back to 185 because that was in my list already. And then that remains the same. 187 should have remained at the bottom of my list. If I redo my truth table then, so my first item is 184. That points me to number 1, 186. That takes me to index 4, 190. That takes me to 2, 185. It's getting a bit smaller. That takes me to, we'll come up here, to number 3, 187. That is the end of my list. And that, if we're correct, is the original list with 190 inserted in as the third element. So guys, I really hope that made a bit more sense and hope you are able to understand it. What I'd really like is for those who didn't do so well in the assessment to revisit your notes and go back and do it again. I know it's a bit long, so obviously just it's important that you do it because this is really key questions. For those who did really well and don't don't necessarily need to revisit. What I would like you to do is to just have a go at programming a linked list. I know you've put one together to add and remove items, but just do a very simple order system similar to this, whereby an item can be added and you can also choose the index position. I don't mind if you don't fully program it, but I want you to actually just tell me the logic. How does that work? What does the program need to do? So you can write it in pseudocode, but I have, similar to what you've already written, but now actually what I want to do is give the user the option to add an item to the end of the linked list, to the array, and use something like this, like an ordering system. It helps give some meaningful values to your variable names, and then I want you to give them the opportunity to say that this might be a priority order, and actually can you put them in third place. And when you do that, how does your array, how does your linked list, get updated? How do you update all of the pointers so that you know where the next item should be found? Okay, so get on with that. There's only a couple of people that need to be doing that. You'll know who you are. You're those who got, kind of above 70 or 80% in the test that you did. Okay. All right. I hope everyone's well. And let me know if there are any issues with this still. Okay.